Hello dear students, this is the continuation video for class 9 students for the chapter water. In the previous video we have already discussed about what are mixtures, what is a homogeneous mixture, what is a heterogeneous mixture. Also we have discussed about what is solution, what are the various different types of solution, such as saturated, unsaturated and supersaturated solution. In this video we are going to extend our studies and learn more about the solutions. So we all have studied that solution is a homogeneous mixture which has uniform properties all throughout. That means that it has a uniform chemical composition and the distribution of particles is also uniform. Here the particles or the solution has a property which is having a uniform physical property. Let us say I am taking a particular salt NaCl or copper sulfate and I am dissolving in water, then NaCl forms a clear solution, and if I filter out, then it will not give out any precipitate. We have already categorized solutions and studied about saturated, unsaturated and supersaturated solution. Now we are going to study about the other different type of solutions, that is the dilute solution and the concentrated solution. I have also told about the standard solution whose concentration we know and we prepare in the laboratory. We have stock solutions in the laboratory which we purchase or we prepare in the laboratory, and all the benches in the chemical laboratory consist of a working solution. Coming to the concentration of a solution. Concentration, as you all know, refers to the particular amount of solute present in a given volume of solvent. The amount of solute present in given quantity of solvent determines the concentration of a solution. Every solution has a particular concentration which can be represented in different ways. We can represent it in terms of percentage by volume, we can represent it by volume, or mass by volume. Dilute and concentrated solutions. The solutions can be of two types. One is a dilute solution and the other one is a concentrated solution. A solution which contains very less amount of solute as compared to the volume of the solvent is called as a dilute solution. Whereas a solution in which there is a large amount of solute compared to the amount of solvent present in the solution is known as a concentrated solution. We can prepare different types of solution of different concentrations in the laboratory by mixing different amount of solute in different volume of solvent. If we mix two different types of components, then we get a final solution whose component depends upon the amount of solute and the amount of solvent. As you all know, a solution is a mixture of a solvent and a solute. If I add a little bit of salt to us water, then the taste of the solution is not that salty, whereas if I add a lot of salt to water, then it tastes very much salty. So the one in which less amount of salt was added can be considered as a dilute solution, whereas the one in which large amount of solute was added can be considered as a concentrated solution. Let us say, take the example of copper sulfate. If we take the same amount of copper sulfate but we decrease the volume of the solvent, or we increase the volume of the solvent, then we get a concentrated and dilute solution. In the first diagram, the same amount of copper sulfate when added to little volume of the solvent, the color of the solution is very dark, or you can see it is dark blue, whereas when I add more water to it, then it becomes less blue. The other method of classifying the solution is based on the particle size. Depending upon the size of the particles, we can classify them into suspension, colloidal solution and true solution. In case of a suspension, the particle size is very large, and in such a suspension or a mixture in which the solute particles do not dissolve in the solvent and it can be filtered out from the solution. They do not pass through the pores of the filter paper, so they remain on the filter paper. That means we can separate it out by the process of filtration. Whereas in case of a colloidal solution, the solute particles are slightly bigger than that of the true solvent and they can be also separated. You have seen many different type of suspensions, and in your day-to-day life the syrups of medicine are a type of that. In this diagram you can see three different types of beakers. The first one is a clear solution where the solute particles have completely dissolved. Second one is a suspension where the solute particles are dispersed, and the third one is another type of solution in which the particles being very large, the precipitate in the bottom of the test tube. So we can classify basing upon their solubility into true solution, suspension, or a colloidal solution. Many a times you must have seen that whenever you take syrups, you shake it. This is just to increase the solubility of the solute in the solvent. Standard solutions are those solutions whose molarity or strength is known to us, whereas true solutions are the such mixtures in which the solute particles are completely homogenized or completely soluble in the solvent. Let us say an example includes sodium chloride in water or copper sulfate in water. Now if I pass light through a true solution and a colloidal solution, the light will pass through a true solution because there is no particles dispersed in it. Whereas in case of a colloidal solution, because the particles are dispersed, it will show Tyndall effect, that is scattering of light. Similarly, the colloids can also be of two types, stable colloids and unstable colloids. Stable colloids do not form aggregates and they are dispersed uniformly throughout, whereas in case of unstable colloids, as you can see, there are aggregates which sediment at the bottom of the test tube. So basing on the particle size, we can classify into true solution where the size of the particle is less than 1 nm, so they cannot be filtered out. Colloidal particle stands in middle where the particle size is between 1 to 100 nm, whereas in case of suspension, the particles are more than 100 nm. That means in case of suspension, the particles do not dissolve in the particular solvent at all. Another important property shown by the molecules in the solution is Brownian movement. Robert Brown found out that the molecules of gases and liquids are always in random motion in the solution, which is known as the Brownian movement. Let us take an example of pollen grain in water. If you take a pollen grain and put it in water, then look it in the and then look under the microscope, you will observe that the pollen grain is vibrating or moving in all directions within that particular slide. This free movement of pollen grain was because the particles of water are also moving within the solution. The colliding water molecules force the pollen grains to move as well, and this motion is known as the Brownian motion. In this particular picture, you can see that the gaseous molecules are also moving in all directions, thus showing Brownian movement or rapid random motion in all directions. So they collide with each other and also with the walls of the container. Another experiment which you can do is also by putting a drop of milk in a microscopic slide and then observing it under the microscope. You will observe that there are small particles of fat which are moving randomly in milk. This is because the water in molecules in the milk are also moving and pushing the fat particles within the solution. Thus the particles of a solution show a different type of movement which is known as the Brownian movement. Now let us discuss about solubility. Very important part which comes in the examination and also is important for your knowledge. Solubility of a solute in a particular solvent is defined as the amount of solute in grams which can dissolve in 100 gram of the solvent at a particular temperature to give a saturated solution. Here the two important words or the keywords are 100 gram of the solvent and particular temperature. Remember, if I change the volume of the solvent and the temperature, then the solubility will also change. Or we can also define it as the amount of solute in gram moles which can dissolve in 1 kilogram of the solvent at a particular temperature. The various factors affecting the solubility include: first is the solvent. We all know that a particular solute dissolves in a particular solvent. Like dissolves like. So the solubility of a solvent depends upon solute in a solvent depends upon the type of solvent. If the solvent is suitable for that particular solute, then it will dissolve in it. If we increase the volume of the solvent, then the solution will change from a saturated solution to into a unsaturated solution. Coming to the effect of solute and the type of solute also changes the solubility. The same solvent can dissolve two different type of solutes in different amount. For example, let us take NaCl and sugar. If I take a particular volume of water, then 5.3 moles of your NaCl will dissolve, whereas only 3.8 moles of your sugar will dissolve. That means NaCl has more solubility in water compared to that of sugar. Effect of temperature. Change in temperature has a very important effect, but it is not uniform for all compounds. It changes with different types of compound. Usually, the solubility increases with increase in temperature, but it cannot be taken as a general concept. The solubility of compounds like lithium carbonate, calcium chromate, this decreases with increase in temperature, whereas the solubility of gases in water also decreases with increase in temperature. Effect of temperature on solubility of ionic solids. In case of ionic solids, with the increase in temperature, the solubility increases. But this is not true for all the ionic solids. In some ionic solids, there is a stable increase, whereas in some cases, the increase is not stable. Now, um, in this slide, you can see there are various different lines in a graph. On one side, we have shown the solubility of the various different types of solutes, and the other side, temperature. So, by increasing the temperature, you can see that for some solids, there is a straight line showing uniform increase, whereas in other cases, it is curves. Some curves are increasing or has a upward trend, whereas some curves have a downward trend. This tells us that the solubility of all the various different types of solutes in solvent are not uniform. What is a solubility curve? A solubility curve is a data-based graph comparing the amount of solute that can dissolve in a given amount of solvent at various temperatures. Solubility curve is obtained by plotting the solubility of substances at different temperatures against these temperatures. If I am taking a particular solute NaCl and if I am checking the solubility of NaCl at different temperatures in different amount of solvent, then we call it as a solubility curve. The solubility curve is a important curve that is useful in the chemical laboratory and also in various different fields. From the solubility curve, we can derive various informations, like we can compare the study of solubility of different solutes. We can also check the solubility of a solute at a particular temperature. Also, we can know the change in solubility when there is a change in temperature. In this graph, you can see that we have compared the solubility of potassium nitrate and sodium chloride, and if we have taken a fixed amount of solvent, that is 100 grams of water. At different temperature, potassium nitrate shows an increasing trend, a sudden increase, whereas sodium chloride doesn't show much significant change with the solubility. So by using this solubility curve, we can get various different types of information. Thank you so much for watching the video. We will have one more video based on the various different types of substances and their solubility in water.